Today we're going to talk about graphing lines. We're going to go back to some Algebra 1 concepts. We're going to make several cards. When you need to write something down, just pause the video and then hit play again after you've written them down. So you can see on the graph here I have drawn the line y equals 4, and I want to point out a way for you to remember that this is y equals 4 and not x equals 4. It looks like it's a line right above the x-axis, but it's not x equals 4. It is instead y equals 4. And I want to show that to you by just showing you some points that are on that line. So I made us a chart here for us to try and keep track of what some of these points are. So it looks like this point right here where I have the cursor is the point 0, 4. This point here is the point -2, 4. This point over here is 3, 4. And let's go one more. Let's say this one here, I believe, is 8, 4. So, what did all of these points have in common? I think you can all see they all have this second number, or this y value, that's 4. That's why we call it y equals 4. Okay, so let's remember that always and never mix it up with x equals 4 again. So next we're going to draw the line x equals -6. And as you can imagine, all of the points that are on that line have the x value of -6. So you can see this line in red. I should probably have some arrows on it. But you can see that it is a place where I've got all my x values equal to -6. And that's why we call it x equals -6. This is -6, 0. This is -6, 1. This is -6, 2. -6, 3. X value is always -6. And so we call it x equals -6. Please make sure you got a card with that. So for this one, you can make an x and y intercept card if you want to, or you don't have to. But basically, this point right here, where we cross the y-axis, is called the y-intercept. That's the y-intercept right here. Okay, that's the y-intercept. And this one down here, this point right here is the x-intercept. It's where it crosses the x-axis. This is the point 5, 0. So we've got a y-intercept here, and we've got an x-intercept here. You may or may not need to make a card for those. Okay, for this one, you definitely want to have a card. This is the slope formula. And I want to point out that this 2 is below the y. It's not up here, because that would make it an exponent, right? So y2 minus y1 over x2 minus x1. I know you did this formula last year. Also on that card, I want you to make sure that you write down rise over run, rise over run. That means it's up, down, over, run. When you run, you go sideways. Okay? It's rise over run. That's not a very good picture, but okay. Another way we might think about it, it's the vertical change over the horizontal change. So make sure you've got all of that on your card. Okay, so there are a few different ways for us to write the equation of the line. The one that most of you are probably most comfortable with is the slope-intercept form of a line. So make sure you make a card. Slope-intercept form of the line, and on the back of the card we're going to write y equals mx plus b. M is the slope, and b is the y-intercept. If you didn't know that, make sure you write it down on your card. M is the slope, b is the y-intercept. So for example, if I have y equals -4/3 x plus 2, then I'm going to put a point at the y-intercept of 2. Grab a pen here. Let's see, I'm putting a point there. And then I want a slope of -4/3. So that means I'm going to go down 4. 1, 2, 3, 4. And I'm going to go right 3. 1, 2, 3. Now, alternatively, I could have also gone up 4 and left 3. That doesn't fit on my graph so well, so I didn't do that, but I easily could have done that. Then I'm going to use a straight edge to connect the dots and extend them out. So I've got something that does this, right? Using a straight edge is important. You guys can use the templates for that, and I'm just going to extend this out a bit like this. Should have arrows on it as well, so I'm going to add arrows to mine. Okay, I don't think the arrows worked, but anyway, you get the idea. So now let's explore the 3 different ways to write the equation of a line. We've already got the slope-intercept form of a line, y equals mx plus b, but there's a real important one here called the point-slope form of the line. I want you to make sure you make a card for that. So on the front it'll say point-slope form. Okay, here's the equation for the point-slope form of a line. So when we have a point-slope form of a line, we've got a place here to put the point, x1, y1, and a place to put the slope. So really, it's very similar to the slope-intercept form of the line. It's just that with slope-intercept form of a line, we have the slope, and then we've got the y-intercept. Y-intercept is just a point, so it's not really that different. I'd like you to also make a card for the standard form of a line. Now, this isn't one that we are going to be using as much. You'll just see that you'll have equations given this way, and then you'll have to reorganize them so that you can use them to graph. So that might be something like, I'll type 3x plus 4y equals 10. Okay. This equation, the way it's written, doesn't really tell us any points you're going through, doesn't tell us a slope. Okay, we got a 3 in front of the x, but that doesn't mean that that's what the slope is. Okay, in order to know what the slope is, we've got to have it in one of these 2 forms like this, y equals mx plus b, or in the point-slope form. So let's do an example now where I want to find the slope of the line through 2 points, -2, 7, and 8, -6. I'm going to use the formula. Okay, so I'm going to write 7 minus 6. Okay, those are my 2 y values. 7 minus 6. Then I'm going to write -2 minus 8. When I simplify, I get -13/10, or 13 over -10. Now you can see here I've written the numbers in the opposite order. Here I started with the second point, -6 minus 7 over 8 minus 2. Sorry, I just fixed the denominator there. 8 minus 2. Either way, I get -13/10. So it doesn't matter which point I use first. The important thing is if I use the second point first for the y value, I got to use it first when I do the x value in the denominator. But notice I've got y's here and x's here. Rise over run. It's very common to mix those 2 up. Okay, so now let's practice writing the equation of a line where I know what the slope is and I know what one of the points are. So what I do is I follow the point-slope equation of a line and I just fill in the numbers. Well, I want to know what y is. Well, I leave y there because I need to have y in the equation. And I'm going to write minus, just like the formula. Then I'm going to fill in y1. y1 is the number 5. So I type 5 equals. Then I fill in m, which is the slope, 3. So I type the number 3. Then I'm going to type that x, because every equation of a line is going to have an x and a y in it, except when it's vertical or horizontal. In this case, it's not. This is a slope of 3. So I'm going to type the x, just like that, and then I'm going to subtract the x value of my point, which is -1, so -1. And I'm going to close parentheses. Now I'm going to simplify that just a little bit, so I have y minus 3 times x plus 1. And that's fine, just to leave it like that. I know you could from here put it into the y-intercept, slope-intercept form of the line, but this line right here is absolutely fine. Oh, except that I made a mistake, so we're missing a number. We got y, we don't even have an equal sign. Look at us here. All right, so there it is. So now I have y minus 5 equals 3 times x plus 1. It's the same as this one. I just simplified the minus 1. Now let's say that I want to graph the line y minus 4 equals 2 times x minus 2. Okay, so I've got the point-slope equation of a line right there for you, and then we're just going to pick out what all our values are. Okay, so first of all, the slope is easy to get. My slope is 2, so I'm going to type that. Slope is 2. Now I have to figure out what point I'm going through. So the point that I'm going through, here's the x value. I have x minus 2. Wait, x minus what? X minus 2. So I'm going to type the number 2. That's the x value. Same thing here. I've got y minus 4. And the equation is y minus what? Y minus 4. So the y value is a positive 4. So I've got a point and I've got a slope. So I'm going to start with that point, the point 2, 4. So let's get a little pen here. I'm going to use red. So the point 2, 4 is here. And I'm going to put a point. Now I have to apply this slope of 2. 2 meaning 2 over 1, right? So that means that I've got to go up 2, 1, 2, and over 1, and put a point. Up 2 and over 1, okay? Can't go any further, so I'm going to go instead, starting at the beginning, down 2 and left 1. Down 2 and left 1. That's fine. Then I'm going to use a straight edge to draw a line, and I'm going to attempt to go through these things and make it pretty straight. Let's see how I do. Okay, so I'm going to continue with that line. It's got a slope of 2. And you'll notice that if I am going from left to right, I'm going uphill. See how I'm going uphill. You'll notice also I've got arrows on either side here, okay, because this is supposed to go on forever and ever. So now let's say that I'm given 2 points. 2 points, I don't have a slope. Well, I know how to get the slope. I just have to use the slope formula with these 2 points, and that'll give me a slope. Okay, so if I apply the slope formula, I've got 4 minus 5 over negative 3 minus 1. Again, it doesn't matter what order I do the points. I write them down in the formula. So I have negative 1 over negative 2. That's the same as 1/2. So I'm going to use the point slope equation. I'm just going to choose one of the points. It doesn't matter which one. I think I'm going to go with 4, negative 3, and I know what my slope is. So I'm going to fill in here y minus, I'm going to use the number negative 3. Then I'm going to write the slope, which is 1/2. And then I'm going to fill in x minus, using that x value that goes with it. That's the 4. And I'm done. This is fine. This answer, well, actually, these minus 3, I should make that into a plus. But other than that, what I have here is really a finished answer. I don't have to put it into the slope-intercept form of the line. I could write y plus 3 equals 1/2 times x minus 4, and that's fine. Okay, if I want to know what the slope of this line is, now this is in the standard form, and it doesn't tell me what the slope is. What I want to point out is the slope is not negative 7. You can't just assume that whatever number's in front of the x happens to be the slope. You have to have it in the y equals mx plus b format. Y equals mx plus b format. So I'm going to rearrange this by moving the 7x over to the other side and dividing the whole thing by 2. So I'm going to have, starting with my original, I'm going to have 2y equals 8 plus 7x. And I might rearrange that to read 2y equals 7x plus 8, and then I'm going to divide everything by 2. So my answer in slope-intercept form is y equals 7/2 x plus 4. Now I'm going to make sure I'm answering the question. This isn't the answer to the question. The answer to the question, and the question was, what is the slope? The slope is this number, 7/2. So make sure you're answering the question. Okay, so you may recall that parallel lines have the same slope. Okay, let's fill in the blanks there. You can make a card for that if you want, but you should definitely have a card for this one. Perpendicular lines have slopes that are opposite reciprocals of each other. Okay, so let me move those up. Okay, so here are some examples. If your slope is 4, the slope of the perpendicular is negative 1/4. You flip the fraction and make it negative.